Okay, good day, students. I am Jhan Flores. It's Jhan Flores. I will introduce myself later. First, I will like to have a quick disclaimer here. The content and the examples that you're about to see, I have based this from the Paulding County School 2012 to 2022 Relations and Functions Unit 4. I got it from their page, and this is for fair use and academic purposes only. So it's just a citation. Thank you so much. Now we are going to start chapter 3, Relations and Functions. So hello, I am Miss Janry Flores, your tutor, your math tutor, and homework help, I guess. So if you have concerns and questions with the video that I'm presenting today, like the examples, the exercises in here, I can entertain your concerns through Gmail. So janmariearenas at gmail.com. I don't respond that quick, but I'll assure you I will do my best to help you. Next, so our objectives for the day. Uh, the students will be able to define a function. Then the students will be able to define a relation, of course. You should be able to present a relation in three ways. The three kinds of ways to represent a relation would be a table, through mapping, and of course a graph. Of course, you should be able to plot points in the end in a graph. Okay, before we start with the whole examples and exercises, let's define what a relation is first. So a relation, it is a way to define any relation between inputs and outputs. So what is the input here? So here, see, a relation between two variables, x and y, is a set of ordered pairs. And before we discuss what ordered pairs are, the x, so this is the input, so x is the symbol for our input, then y is the symbol for an output. So how can we picture this? Why is it this way? Why does it work this way? So suppose that x is like an ingredient to your product, and y is depending on it so that you can complete your product. Suppose that your product is a cupcake, and now x serves as the baking ingredients. So we are going to go through the whole baking process. That is what x can actually do. It's an independent variable. And then after that, as we complete the whole process of baking, we are able to produce Y, which is the output, the product itself. So that's how you can visualize things if you couldn't fully understand it. I wish I had more pictures, but it's only limited to this. Okay, so an ordered pair consists of an x and y coordinate. So ordered pair, as we mentioned, that this one is the, okay, let's say that this is just simply the one with a number, then the comma. So x, comma, y, then it's in a bracket, a parenthesis, then brackets. So there's like many sets, then boom, you got ordered pairs. So there are x values, which I said are the input, independent variable, and it's known as domain. Then we got the y values, which is the output, dependent variable, the range, domain, and range. Okay, so how are we going to apply these? Okay, so what makes this a relation, or what makes a relation in the first place? That's what we're all wondering, right? So to form first the relation, we have to have the coordinates, the x coordinates first. So since we understand that the domain right here is 0, 1, 2, 3, 4, 5, we put the x coordinate here in the left side. So this is 0, 1, 2, 3, 4, then 5. Those are the domain, also known as your x coordinate. Then what is the range? So we got -5, -4, -3, -2, then -1, 0. So these are the range. So these are your y coordinates. also known as y value. See, you have a lot of ways to call it. So it can be called as x values, y values, x coordinate, y coordinate. So it also depends upon your teacher's instruction, but I prefer to call it as the coordinates. Especially, we are going to use these for graphing. So I usually use the term coordinates. Now, anyway, okay, is this a relation? How can we understand if this is a relation? The whole graph in here. So we got 4, 5, 0, 9, 1 as the values for your inputs. And the output is only negative 2 and 7. I apologize for how it's represented. It's a little compressed in a Google Meet recording. Um I can state that this is the input. So here we got the domain again. So the domain and its pair for each uh, for its range is that if we're gonna write this in an ordered pair, it's going to be 4 with negative 2, negative 5 with negative 2. It's an ordered pair. Then we got the range where, of course, the other range, 7. We're going to represent it as an ordered pair, 0 to 7, 9, and 7. Then you're going to put that 1, negative 1, then comma 7. They're going to close the entire bracket. So that's how it's going to be represented. If it's only asking what is the domain, you're just going to gather the domain, get the brackets right here. Then there is 4, negative 5, 0, 9, comma, comma. That's how it goes. That's the flow. Then that is the range where you put negative 2 and 7 because it's the only one written below here at the output. So an example of a relation. Okay, so this is just a quick example of how we are going to represent the input and the output. However, it's don't be fooled by the graph that I made. How this one is your x coordinate and the children are the y coordinate, obviously. So this is another way to picture domain and range way easier. So Carmel's the ordered pair for Carmel is Carmel, Ammon. Tapos we got Carmel, Nathaniel, Carmel, Sebastian. So these are going to be hers, let's say, if we're going to represent it in an ordered pair. But as a table, it should be like this. Then we got Jude to Madeline. Then we got Ella to Madeline, if it's an ordered pair. But as a table, it's represented this way. So again, the domain is the mothers, and the range are the children. So let's move on to the types. So we got two types of the relation, which is many to one and one to one. However, let's discuss this first. So this is also an example. Let's say an average adult generates about 4 kilograms of waste daily. The table shows how the number of adults affects the amount of waste. So let's say one adult generates about 4 kilograms. So it's given in here in the situation. Let's let it be one represented here as the x as the domain, then 4 represented as y as the range. Then of course this is what you're gonna do. So we're gonna multiply it by here, the first data. So 2 times 4 equals to 8. So 2 adults generate about 8 kilograms of waste daily. How can we identify which is the independent variable or which one is the dependent variable? Okay, it's simple. Okay, so what is the independent variable? The number of adults, so the total number of adults. It is the independent variable because it can stand alone. Then, of course, its relationship with the waste generated, which is the dependent variable, the amount of waste generated daily. So the relation between these two is that this one, it actually produces the output. So without the ones up here, the data up here, the x coordinates that we say right here, we wouldn't have these here, the ones below. Okay, so 1 to 1. These are already given this is obviously X, then there's obviously Y, then you just plot it on the graph, and it's easily understood. But however, this is how you identify that this is 1 to 1.